Welcome to Embedded. I am Elecia White. I'm here with Christopher White, and we are excited to talk to you, Jason Derleth of the NASA Innovative Advanced Concepts Program.
Hi, Jason. Thanks for joining us.
Hi, both. Thank you for having me.
Could you tell us about yourself as though we were meeting at the lunch table of a conference?
Well, I'm a bit of an odd duck, so I have to keep it short. I'll start with my schooling, which I started late, actually. I was 26 when I went to school, and my undergraduate degree is in philosophy. My master's degree is in aeronautics and astronautics engineering, and yes, it was quite a trick to go from the one to the other. Yes. And after that, I got the great opportunity to work at JPL. I worked on the Curiosity rover that's on Mars, just a little bit, not a lot, and was called into NASA headquarters for a quick study, a 90-day study back in 2005. They liked my work, so they asked me to stay, and in 2005, right when I had started working as a detailee from JPL to NASA headquarters, I met my wife, and so I decided to convert over to being a NASA civil servant at NASA headquarters, and I have not seen a robot since, hardly at all, and it's really sad.
And then you were at NASA doing things, but then you got into this advanced concepts thing. Yes.
Headquarters is a funny place because we follow what the presidential administration wants us to do. Mm-hmm. And when I first started, I worked in a group called Program Analysis and Evaluation, which was under Dr. Scott Pace, who is now head of the Space Council. And in that group, we did a lot of analysis of other programs and tried to figure out how to make them better. And the other programs didn't always like us trying to help them.
Yeah, I can imagine.
And so eventually, PA&E wound down. There's still a little remnant of it left in the budgetary group at headquarters, but I was fortunate enough to go and work with Dr. Jay Falker when he was starting up this program that had been canceled a few years earlier. It was originally called the NASA Institute for Advanced Concepts, still NIAC, but the NASA Institute. And he was restarting it and allowing civil servants to propose to the program as well. And so we renamed it slightly to NASA Innovative Advanced Concepts. And I've been there ever since. So it's been 10 great years at NIAC. So,
which is primarily what we'll be talking about today. But before we get into it, we want to do lightning round, where we ask you short questions, and we're hoping for short answers. And if we're behaving ourselves, we won't ask how and why and are you sure?
Okay.
Favorite non-terrestrial solar system body?
Non-terrestrial. Venus.
Craziest idea that actually worked?
In space? Let's see. Or in NIAC or...
Anything.
Okay. I'll have to go with one that doesn't sound that crazy, but it's really difficult, even though it sounds kind of simple. If you take a Mylar balloon and put it inside of another much larger Mylar balloon, which is a weather balloon, and you take that first balloon, which is a spherical balloon, and illuminize the inside of it to be a reflector, and then have a secondary mirror inside of it that can adjust its shape to account for flexing of the Mylar, and then send the whole package up to 110,000 feet, you can do radio astronomy with a 10-meter reflector for probably less than $100 million. And it's super exciting, and we're going to be able to fly, NASA's going to fly one of these in just 2 years, launching it from Antarctica. And I hope I get to be there. And it's just this crazy thought that maybe you can make just a really super thin telescope and get it up above the atmosphere just far enough. It's not a spacecraft, so it's much less expensive, but you can do some really great astronomy with it.
That's pretty crazy.
It's fun. It's really cool. And the NIAC fellow who did that actually won an award from another part of NASA of $35 million to do a half-size prototype of 5 meters. And that's what's going to launch in hopefully December of 2021, if everything goes well.
All right. Favorite King Arthur Knight?
I'm having problems remembering the name, and it's the main character of one of my books. I know, it's horrible. Thank you, Dinadan. Dan. See, he goes by Dan. He's embarrassed. That's the whole point, right? So, thank you.
I didn't know if he was your favorite.
Yeah, absolutely. Really neat guy. Honest to a fault. So, yeah, that book was a weird one because I decided to write something for NaNoWriMo, National Novel Writing Month. And I wrote this kid's book of 54,000 words in 27 days. So
see, it's popular. NaNoWriMo's fun.
Yeah, it is. It can be. You just have to have just enough time to spend time writing, and I don't have that anymore with the small kids in the house. So,
one more. Is there a technology most people don't know about now that will have a large impact in our lives in 20 years, over the next 20 years?
Absolutely there is, but I couldn't tell you what it was. So I know that's a sort of a cop-out answer, but it turns out that when you look at the people that invest in these ideas, the venture capitalists, even they are so bad at predicting which technologies will be successful and which ones will fail that something on the order of 19 out of 20 fail to make large amounts of money. But the 20th one makes so much money that they can be venture capitalists, right? So if I had to guess, I saw a technology conference a number of years back up in New York City, and they were talking about a really interesting hydroponics system for growing plants. Essentially, what you do is you take a container, those things that they put on trains or on the back of trucks or ship them in ships, and you can build a multi-layered vegetable growing system inside of that trailer using LED lights and hydroponics, and they were doing interesting things by providing different nutrients and then doing taste tests. And it turns out you can do something like a 1/4 acre inside of a single container. And every time that they gave talks, they would hand out vegetables that had been grown in this thing. And to a person, whenever a person tasted one of these vegetables, that's the best vegetable I've ever tasted, whether it was a lettuce or if it was carrots, whatever it was. It was just, they had tweaked the nutrients and the lighting and done everything they can to make the vegetables super nutritious and super tasty. So that's a really cool technology. And if it catches on, you can imagine what we could do with something like that. I'm thinking, oddly, I have this thing with names, and I hate it because sometimes names just go right out of my head. What's the capital city? Coruscant is the capital city in the Star Wars universe, right? Capital planet, I should say. And if you remember from seeing videos of the ships, the CGI of the ships, there's no green space whatsoever on Coruscant. And the theory back then when they wrote it was that they have other planets to grow vegetables and they import them. Well, maybe they just have these containers sitting on the top floor and the bottom floor and the middle floor. You don't even have to travel very far to go to get your fresh veggies, right? So,
locavore. All I have to do is go out to my garage.
Exactly.
Okay.
Garage vegetables, though.
So NIAC, it's kind of like venture capitalism.
Kind of. I like to think of us as the venture capitalists for NASA, looking 10 to 30 or more years out in the future and trying to figure out what might make a big difference for us, and then funding little startup ventures for each of those. And we've had over 200 little startup ventures, and a few of them have paid off fairly well, although at 10 years out, and we're supposed to, if we're doing our job right, be a minimum of 10 years from implementation, you wouldn't expect too much to have succeeded so far.
It makes it kind of exciting for the next 10 years.
Yeah, it does. Really, I'm hoping a lot of these come through in the 10 years.
Who is NIAC for? I mean, who is it supposed to benefit?
Well, that's a very interesting question. It's supposed to benefit all of its stakeholders, right? So we think of the stakeholders of NASA as being the astronauts that utilize the technologies that are being developed, the scientists who are utilizing technologies to do deep space satellites, whether they're telescopes or rovers or planetary orbiters, or cometary orbiters, that sort of thing. All of those scientists that are trying to probe the secrets of the universe. We also think of people like Congress and the average everyday person in the United States, or even citizens of the world. So NIAC is kind of unique. I don't know too many programs that take their final papers and just put them up online, but that's what we do. Every NIAC research ends with a final report, and we take the final report and put it up online. There's a bit of a process to get a federal website to have a scientific paper. It's got to be screen reader readable. So any equation that's in there or any diagram or table has to have audible text describing it, so that someone who's blind and surfing the internet can still have the paper read to them. And then that takes some time. And when we're dealing with technologies that involve space, we have to be careful not to put any state secrets up. And so we have to go through the ITAR process. It's called the International Treaty for Arms Regulation, I believe. But once those processes have gone through the papers, we put them up for free on the internet for anyone to read and enter the sort of grand conversation of academic type papers, research papers. And even if something is not successful in proving that what their dream or their concept would be will work, that's still valuable. Saying, hey, we thought of this really cool idea. It doesn't work right now. Here's why. If things change in the future, it might be an interesting path to go down, but at least for right now, don't bother with it. So we put our successes and our failures up.
I was recently reminded that we haven't really told listeners what NIAC is.
I'm sorry. So let me tell you a little bit about NASA, and we'll zoom in, so to speak, on NIAC. So NASA is, of course, the National Aeronautics and Space Administration. And we divide our work at NASA up into 4 major lines of business that we call mission directorates. The Aeronautics Mission Directorate, which does all things aeronautics, of course, almost all things aeronautics anyway. The Science Mission Directorate, which has 4 subdirectorates, 4 big sections: planetary science, heliophysics to look at the sun, our sun, astrophysics to look at other suns, other stars, but also how stars and planets form, and earth science, which is very important as well, where we take satellites and point them down and look at weather and sea temperatures and moisture, content of vegetation, all sorts of different things, as well as the atmosphere in between the satellites and the ground. And there are even some earth science projects that go out and do instrumentation on the ground and look at things. Actually, planetary science also does exploration of our own planet a little bit, sort of as a analog for other planets. We'll go to the high deserts and take a look at what Mars might be like, that sort of thing. So after Science Mission Directorate, there's the Human Exploration and Operations Mission Directorate. That's the group of folks that everybody thinks of when you think of NASA. This is the astronaut off. That's right. That's right. They have astronauts, all of them. So there's a group of folks there concentrating on operating current equipment, which in this case is the International Space Station. And there's another group of folks that are working on development of new systems. And that's the Artemis program, going back to the moon by 2024. And bringing the first American woman to the surface of the moon will be very exciting. Hopefully it will happen in 2024. And after that, there's another mission directorate called the Space Technology Mission Directorate. That is a smaller mission directorate, about maybe the size of aeronautics or a little bit larger. The bulk of the money gets spent, about 50% of it, on human spaceflight. We get about $20 billion a year in total budget, and 8 to 10 billion, I think it's about 10 billion right now, is spent on the human side. And this is all public knowledge. You can look it up on the internet. You can find NASA's budget and see how much goes to each section. Space technology at the moment is about a $1 billion effort, so about 1/20th, 5% of the NASA budget. And in space technology, we have a number of programs that are dealing with different modes of business. So there's a fairly common program across government called the Small Business Innovative Research Program that funds small businesses to do dual-use technologies, so technologies that will be usable for the agency that's providing the funding, but also could create a new sort of product for that company to sell, and we have a large amount of money, about $200 million, that goes to this SBIR program. We have a large technology development program called Technology Demonstration Missions, which, just like the name says, it actually flies new spacecraft in space to demonstrate technologies so that other mission directorates can then use them. And then we have something called Game Changing, which sits at in between early stage technology development like NIAC and technology demonstration missions. Game Changing takes the technologies from those early stage programs and progresses them to the point where they might be able to be on a spacecraft. And then we have the early stage and other innovative sort of procurement programs in STMD as well. Things like iTech, which looks to find investors in technologies that are companies that will then come in and put their dime down and take advantage of something that NASA has created, whether it's a patent or just a new good idea. And then NIAC is in there in that early stage. NIAC is about an $8 million program, so only about, less than 1% of the $1 billion that is less than 5% of the agency's budget. So it's a very small program in NASA, but it's very exciting. We get to do, like I said at the beginning, we look for things that are 10 or more years away from being used in space. But even though they're sort of on the border of science fiction, and in some cases are taken directly out of science fiction, we only invest in things that we think are actually possible. And in fact, we only invest in things that we think are going to be good ideas. And we have 3 phases of study now. So we have the largest number of our studies is phase 1 studies, new people with new ideas. We give those folks $125,000 over 9 months to check out a new idea that they think is a good idea. And the basic premise is that they take an analysis of the idea. They build spreadsheets, use physics-based models, or even sometimes they'll make experiments in a laboratory to verify that what they're saying is a good idea is actually a good idea. A good example of something that sounds good but might not actually be good is fusion drive. It sounds like a great idea, fusion drive. Well, let's just say that you have a fusion drive, and let's just say that you're the first person ever to make one work. Well, it's going to create a lot of heat, right, to do fusion. How are you going to dissipate that heat in space where you don't have a fluid like the air around us to dissipate heat? You have to radiate heat with a radiator. Well, maybe the radiators and the mechanisms to supply the heat to those radiators are so big and so heavy that the fusion drive actually performs worse than our current chemical drives, right? So that's an example that I use to explain to people why we are kind of odd in that we don't do piecemeal technology development. This is what I was trying to drive down to in the phase 1, and I'm a little bit scatterbrained, sorry about that. But we ask people not to come to us with just a regular technology that they think is great. We ask them to bring a technology and a mission context to put that technology in, to analyze the entire mission rather than just their technology, to show that it's a good idea to build the technology.
So
and
my plan to make a warp drive to attack Alpha Centauri, that's perfectly fine because there's a mission in there.
That's right, it is. And in fact, you can work with some of our other fellows who have come up with not a warp drive, but with a potential reactionless drive, something like the EM drive, but has more physics-based underpinnings. And maybe you can get there. I think, though, that the star there at Alpha Centauri has already attacked the planet too much, though. It's a very active star and has probably scrubbed any life off the surface of Alpha Centauri B, Proxima B, sadly already. So, but that's good. You're already done. You succeeded in your interstellar attack.
Actually, this is a good time to start weaving in the other piece, and that is that I started to submit a proposal, but I got fouled up in the payment system, NSPIRES, which is sort of exciting. If anybody wants to talk to me about that, let me know. But get your DUNS number very early.
Yes.
I had this idea about Curved-Crease origami, and that's because I'm fascinated by origami right now, micro obsession. But I have a lot of experience with sensor arrays. I worked at ShotSpotter where we had 4 microphones and then could determine which direction a gunshot came from. And then by sprinkling these around, we could locate a gunshot. So sensor arrays, I understand how the gradient works, and I can do it for temperature or whatever. But the body that it sits on is often heavy and needs to be machined relatively precisely, because if you don't know where your sensors are, it's very hard to say anything about what direction things are coming from.
Mm-hmm.
And so as I understood more about the curved-crease origami and how much more it's stable than regular origami, and I know NASA has a big history of origami in spacecraft and using those same techniques. I was thinking, okay, well, what if we did sensor technologies that used the curved-crease origami on maybe flexible circuits?
Mm-hmm.
And then we could build sensor arrays that were super light and yet still rigid and still precise enough. And then because I needed a mission, I decided we should use them on the Mars outpost as ring perimeter sensors for wind, temperature, sound, all these things. And then I sent a 1-pager, and that was part of the proposal process. You mentioned there are multiple phases of the NIAC grant, but there's also multiple phases for the proposal process. The first one is a 3-page paper plus a 1-page overview. Is that
correct? Yes. And the reason for that is we get 200 to 300 proposals per year for only 12 to 16 funding slots. And we don't want everyone spending all of their time writing an 8-page proposal and getting every word perfect and then finding out that they aren't relevant to the program and they wasted their time. And so we ask for this 3-page white paper from everyone so that we can do a once-over and make sure that everyone is in scope for NIAC. You could have the greatest idea that's ever been proposed, but if it's an incremental technology development that's going to use laboratory time to work out the next step in, say, a material property, that's not NIAC. There are other programs for that sort of thing. And so we would let you know after a 3-page white paper that no, you're not really applicable. Don't waste your time, please. So go on.
And then they get invited to do the phase B, which is a 6-page, 10-page?
8-page white paper. And basically you take the 3 pages that you wrote before, which was a summary of your concept, and add in all of the planning that you're going to do, that what you would do if you won. So who are you going to work with? What will you produce? And how long will it take? And all of that sort of stuff.
And you just finished judging these more detailed proposals.
Mm-hmm. Yes, we just finished our technical panel reviews. We have peers, scientists come in and engineers, experienced folks come in and review these full proposals for us and give them a score. After we're done with the technical panel scores, we take them around NASA to make sure that there's no duplicate work happening anywhere else, and also gauge interest from potential customers. And then we take that whole package to the source selection official, and that's my boss. And this year he will choose 12 to 16. I think it will be closer to 12 this year because the budget is a little bit wonky with this, the first year of our new phase 3 concepts.
So do you do much judgment of the proposals?
I'm part of the first turn, that going from the Step A white papers, the 3-pagers, to the full 8 pages. We have our internal group do that. So it's just me and Dr. Ron Turner and Dr. Mike Lapointe and John Nelson, who's a contractor. We go through and discuss each and every white paper. We all read, all 4, and make sure that they're in scope. And then we sit in the technical review panels, but we want the technical review panels to be completely independent of us. And so we literally don't even run the panels. We nominate a chair, and the chair runs the panels for us, and they give us their own unvarnished, shellacked, that's of course a contradiction in terms there, but you get the shellacked, meaning the old phrase of I gave him a shellacking. So, they're mean sometimes. They can be quite mean, the technical panel reviews. They need to be, because we're trying to go up to the edge of science fiction, but not over. And so we want to make sure that these things are feasible. And so they're tough reviewers sometimes. But we tell them what we're looking for, and looking for transformative technologies. And they help us find them and score them and all of that. So.
And how important is the 1-pager for that piece?
So the overview chart that has sort of a picture of what you're considering, and then 3 boxes that explain what is your technology, how will you do the work while you are being funded by NIAC, and what effects would the technology have if it were fully successful, is used to represent your entire proposal at every step along the way. And when we're having the discussion about the proposal, all of the reviewers have computers in front of them with the full proposal in front of them. They all have read it in advance, and they have individual notes, but we put on the projector that 1-page overview, and that helps remind everybody what this is. And then when we take that to the mission directorates, to the other mission directors, to find out if there's any similar funding going on elsewhere, we bring those 1-pagers and we describe what the technical panel said and whether or not it was good, and then the mission directorates weigh in. And when we go to the source selection official, we describe the technology, again, using that 1-pager. So it's actually really important to have that right. Now, that said, we're evaluating the proposal and not that 1-page overview. And so the proposal is really important.
These proposals are pretty all over the place. You're not...
Mm-hmm. Mm-hmm.
How much do you have to study in order to understand them?
Well, every year we have these technical reviewers come in, and we hire them based on their technology expertise. So by getting experts in the field, we all learn a little bit, because it's important to have experts that can tell you whether or not this has been done before, whether or not it's feasible in the long term. But it demonstrates why we ask for concepts as opposed for individual technologies, because what we want are high impact technologies, not just technologies. And so if you take your, for instance, flexible circuits using Curved-Crease Origami, and you show that you can do something that nobody else can do, because you can pack this into a launch vehicle better, they will distribute themselves around Mars more efficiently using the wind, whatever else you come up with, we'll actually likely bring in someone who's done origami for spacecraft before, for something like that. Or we'll bring in somebody that's worked with someone that has, at least, but in that case, because it's very specific. But we do know folks out at JPL that have done this, and we probably would call one of them up and have them come and be on the review. And they would represent the idea to the rest of the panel and be the first ones to introduce it and describe it. And so we don't have to study as much because we hire these experts to come in and do it for us.
I'm very seldom willing to sign up for meetings, but this sounds like it would be kind of a neat meeting.
Yeah, it is a fun meeting. Unfortunately, we don't allow anybody to attend those meetings pretty much.
Makes sense.
Mostly because we use some of the same reviewers every year, and we start out the meeting by saying, hey, this is, Vegas rules. What happens in Vegas stays in Vegas. You need to be, as reviewers, you need to be able to be completely honest with us. And if you meet one of the proposers and say, hey, I'm glad you got funded, I reviewed your paper and all of that, then they'll let everybody else know that you've been a NIAC reviewer, and then you will have something in the back of your head every time you start to talk about someone. Oh, I can't be honest. We need the complete honesty, because to be frank, if NIAC were to fund something that was beyond science fiction, it could mean the death of the program. If we really truly do something that's not feasible, that has no justification for it, if it's science fiction, well, that's not good use of the taxpayer dollars. And so we rely on these people to tell us the truth. And to close it out again, I'm sorry I didn't finish my thought earlier. What we look at is not just the technology, but also how much it impacts the mission or makes it feasible where it wasn't before. For instance, with Curved-Crease Origami sensors, you might be able to get close to the recurring slope lineae on Mars, where it appears that every season there's liquid water or something else is going on there that we don't know. If you could drop these and get them close, those slopes are too steep for a rover to ever drive up. And so sampling that and understanding what it was and being able to track that motion of the darkness across that, sense when that recurring slope lineae occurs, and figure out whether it's water seeping through the ground or if it's some sort of recurring wind pattern that's changing the color of the soil, that would be extremely exciting, because nobody can do that right now.
Ron suggested showing how size, weight, and power, SWAP was his acronym, is reduced for a sample mission. And you asked about how large an array I could create. Both of these things I was kind of hand-waving. I was hoping to investigate flex circuits when the time came, and I was kind of hoping to figure out just how much lighter it could be. I mean, I knew it could be lighter than metal for sure, but to make a whole sensor array, you need a power supply. So that's, their calculations. How far along do people need to be in order to create a proposal? I mean, clearly I'm not ready. I totally get that. But,
well, no, actually, you're probably pretty close. We allow, essentially the artist holding their thumb up to measure how big a person is or a building, and then using their thumb to transfer that measurement to a canvas. It's not fair to ask a proposer to do their entire study so that they know enough to make a proposal, right? So what we're really interested in, though, is making sure that those things are in your work plan. So you might have a back-of-the-envelope equation for sizing a power supply, and you put that into the proposal and say power goes as this and that and the other, and therefore a battery would need to be approximately 6 grams or whatever the correct measurement is, and you show the equation in the proposal. And then in your work plan section, you would then say the back of the envelope given in this proposal is insufficient to know if this will actually work. And so we will spend 1 month performing power calculations and sizing the system. And that's how you get in, and then you get to do all of that work that is so exciting and interesting, because that's really the nitty-gritty of designing a space system, but you're getting paid to do it, right? So that's the work that we want to fund, because when you're done, you'll be able to say, well, theoretically, from my spreadsheet optimization, this will weigh this much, and it will be this foldable, and we'll be able to pack this many in a cubic centimeter, and that means that the mission looks like this. And that's really exciting. It can be really exciting if it comes out good. And then if it does come out good, the next thing is a phase 2 study. I've described the phase 1s pretty well. A phase 2 study is $500,000 spread over 2 years to do the work necessary to raise the technology readiness level of your concept by 1 or 2 points. Now, the TRL scale is from 1, which is a basic idea has been identified, all the way up to 9, which is, well, it's flown in space and we can use it again now. And so NIAC looks at 1, 2, and 3 for entry into phase 1, and exit would be 2, 3, or 4. And for phase 2, it's 2, 3, or 4, and then 4, 5, or 6, hopefully. But, sorry, 3, 4, or 5 exit. And then after that, once a year for really special concepts, we get to possibly sometimes choose a phase 3. A phase 3 is $2 million over 2 years, and it's meant to bridge the gap from a concept level to an implementer. So we only give phase 3s when we think that more risk needs to be eliminated before a customer would truly accept this as a possible technology to use in space or in the air for aeronautics. And you have to have a customer identified and a paper saying that they are interested in your technology at the very least. If they're not going to kick in money, it's even better if they kick in money for phase 3. So, and that's pretty much the whole program now. That's how we get up to about $8.5 million total spent, and some of that is paying salaries of the people that operate the program, and then paying for the technical panel reviews is expensive as well. And then all the rest of it, probably 90% or so, is spent on the studies.
How do I decide if an idea is too obvious?
Ask, I think. Find someone at a conference and ask. One thing that I think for you that you should do is to sit down with somebody who does this and brainstorm other uses. Because when you were describing your technology to me again on the phone here today, it made me think of how interesting it would be to have sensors out in space sensing the solar wind or tracking solar flares and looking at the corona and all of that. And from talking with the technical panel members who have looked at concepts like that in the past, I understand that they are very interested in having many sensors all surrounding the sun. And something, if you could come up with a way of distributing those sensors around the solar system and keeping them in place, somewhere in Earth's orbit or closer or farther, depending on where you were looking, it's a really interesting problem. We don't know as much as we think we do about the sun. Of course, the experts in heliophysics know quite a lot, but they still can't tell us where our sunspots went.
That's
right.
When they're coming back.
Yeah, and it's such a giant electromagnetic ball, and it tosses off those flares, and they impact the Earth infrequently, but when they do, it's kind of a bad thing. I don't know if you've heard, I don't remember the name of the event. In the 1870s, it hit the telegraph wires that were crossing the United States and caused such a power surge that some of the telegraph machines burst into flame. If that were to happen today and hit us, it would be much, much, much worse.
All of our satellites, yeah.
And so an early warning system might be enough to turn off at least some of the big systems and save some of them. And we don't have that right now. Now, like I said, it's an infrequent event, so it's not as bad as it could be, but understanding those, and it's especially important right now. I don't know what we're going to do when we send astronauts to the moon in 2024. It will actually be one of the worst times in the solar cycle for solar flares and radiation. So we will have to have some way of guessing whether or not a solar flare is going to come soon And there are probably ways to do that through big data, but nobody's done it yet. And we need to figure it out pretty quickly so that at least we can say, okay, there's no solar flare. We're thinking we're in a 6-hour quiet period. So you can go do your EVA on the surface, probably safely. But, that we can't do that right now. And so that's a big deal.
Probably safely.
Probably.
You're probably fine.
Yeah.
Do you get impossible ideas, things that just aren't viable and you can tell from get-go?
I feel like you're referencing my idea. It's totally possible.
Well, it might be. I do like the idea. So, yes, we do quite frequently get ideas that are impossible. And when we tell folks that they are talking about something that's impossible, they don't always appreciate it.
Sorry.
I've seen folks leave in a huff, sort of storm off in email land. I don't know how you say that. It's not really leaving in a huff, sending me huffy emails, and go off and spend their own money to, quote, prove me wrong, end quote. And then eventually the emails just stop coming, usually. One poor guy.
I want to hear the not usually.
Well, I can't because proposals are proprietary. But there was one guy. This one guy, poor guy. I think he spent $70,000 of his own money machining things and hiring people to make motors and everything. And he was essentially saying that he had found a perpetual motion device. And I tried to explain to him that he had found a perpetual motion device, and he just didn't want to believe it. And I haven't had an email from him in a number of years now, but he kept emailing me for 3 years showing progress and the machine on the machine table and the beautiful things that he had made. And they were very nice, but I think in the end it didn't work. And so he had to stop.
During my failure to get into the payment system, which is required before submitting the proposal, I started talking to you and Ron Turner, who you mentioned earlier. Mm-hmm. And you very, very nicely offered to look at my proposal out of band, not to be part of the process, but to help me understand the process. Do you do that a lot?
Yes. At least 3 or 4 times a year, we'll have people contact us and ask for a review of a white paper out, as long as we don't have a currently open solicitation, then we are allowed to offer not exactly advice, although we can do that as well. But what we try to do is help people understand the program better and help understand what the requirements for a proposal are better. And this has led to, since NIAC is open to anyone in the United States legally to propose, including college students from other countries, as long as the money will be spent in the United States, they are eligible. We get people that haven't done government grant proposals before. That's perfectly normal, and not everybody can know. Yeah, me too. I've never done it. So one of the things that we did actually was Ron decided to go off and start a business and get all of the paperwork done to get into the government payment system. You see, it's really important to understand this type of grant is never given to an individual. It's given to a corporation or a sole proprietorship, a business that is registered with the government, and we can't let you win an award unless we can pay you. And so there are some requirements for the corporation to go through, or for the small business to go through, to get registered with the government. And that involves getting a DUNS number, which is a challenge, as you said, but it also involves a few other steps to get registered. And some of those are new, I think, just this last year, where one of the papers has to be notarized now that didn't need to be notarized before, but apparently people were starting up hundreds of shell companies and doing weird, funky things, and so the IRS requires now it to be notarized, and so that's an extra step. It took Ron about 2 weeks to get registered, but he knew what all the steps were going to be. He understood what they were and had help walking through the system. So I think it's a really good idea to begin doing that as soon as you're interested in proposing to NIAC, even if it's months before the solicitation release happens. By the way, I should let you and your listeners know that we are changing the NIAC schedule. Up until this year, we've been on a pretty stable schedule where we release the solicitation in August, the first week or two of August, and we're moving that back to June. So the first week or second week of June is when we're expecting to release our Phase 1 solicitation. And it has to do with the lining up of many grant programs in the late spring, everybody making their selections and then needing to get all the granting paperwork done by a group at NASA called the NASA Shared Services Center. The NSSC is overtaxed in the April and May timeframe, and it ended up being so bad this year that our grants didn't actually get any money until I think it was 3 months after they were supposed to. And so we're trying to deconflict with other programs so that the folks that win will actually be able to get their money in 30 days like they're supposed to.
So the call is going to open earlier and everything is going to happen earlier. Is that right?
That's right. That's
okay.
right.
That's good to know.
Yeah. And so anybody who wants can send me an email. My email address is jason.e.derleth, and I'm sure you can put it up on your website as well, at nasa.gov. And I can respond to you and read your white paper and give you an idea of whether or not you're applicable to the NIAC program, as long as we aren't in that active competition time period. So during the 6 weeks or so that we have that step A of the Phase 1 proposals open, then I'm not allowed to answer direct questions because that would give a competitive advantage to one person. And that's not what the government's all about. We want the best ideas, not just the ideas that one person who managed to find me.
How important is good writing to the proposal?
It's weird. You're not doing yourself any favors if you misspell things. But if you have a truly good idea and you spell the NIAC program acronym NAIC instead of NIAC, we're going to notice it, but we're not going to strike down a good idea because you had a keyboard problem or whatever, right? So it doesn't help you if you have a lot of grammatical errors. It doesn't help you if you don't put your sentences together in the right ways. But if you have a really good idea, it can still make it through.
Yeah, it's a balance. I mean, you have to, you might be better off getting somebody to proofread it.
Yes. And with the more experience they have at proposing to the government, the better as well. Ron Turner has a saying he likes to say, and that is that NIAC doesn't actually develop technologies. We give concept studies to people so that they can show how good their technology is, so that the end result of the study, you can talk to other people at NASA and sell your technology through the NIAC final report. So we're helping you learn how to sell your system better.
You also do a little bit of work for the SBIR system, the Small Business Innovative Research Grant System.
That's right.
And it seems like there is something similar that happens there, where if you can talk to the organizer before submission, it usually ends up being a better process, and you can figure out earlier if you should submit or not.
Yes, that's true. SBIR is a really interesting program. Now, with SBIR, there is a really good conference that they put on every year now called the Innovation and Opportunity Conference, IOC. And you can meet with the people that are the decision makers for the program at that conference and find out a lot about the program at that conference. I get up and give a talk about what my portion of SBIR is interested in. The program executive for the whole program is there and gives a couple of talks, and the whole team of people that manage proposals is there and all of that. So that's a great 2-day long conference if you're interested in SBIR. Every agency's SBIR is slightly different, so it helps to know about what you're, it's really, I'm sure it's extremely frustrating for proposers.
I mean, I always feel like part of the bureaucracy, part of the rules are to make sure that I understand how to follow rules. It helps if I treat it like a game.
I guess. I think that complex systems like this end up being the way that they are for reasons, and they're not always good reasons, but there usually are reasons. And so NASA does one thing with SBIR because that's how they've managed to find some really interesting technologies that have then gone on to help spaceflight. Whereas the Department of Energy has an entirely different goal for their SBIR program, assuming that they have one. I don't actually know that. But NSF, for instance, has a different set of rules. And it's because the researchers there work differently than they do at NASA, and what works for them and working with contractors through the SBIR program is going to be different for them. It's unfortunate, but it's kind of like when you go to somebody who's been working in feet and foot-pounds and inches and say, you really ought to use the metric system. I'm looking at you, Marshall Space Flight Center. Sorry. But then they turn around and they say, look, you're probably right, but we've been using foot-pounds and pounds force for rocket engines and inches and everything else for 60 years. And we're not going to change because our engineers are trained this way. We're going to need different software. It's going to make it horrible for 2 years while everybody converts over. And do you really want to have a rocket blow up because we switched units? No, you don't. So we're going to keep doing that. Thanks. And they are 100% right, as is evidenced in 1999 by JPL doing some Mars regolith braking on one of their spacecraft.
They shouldn't have named it Beagle. Anybody who has a Beagle knows you should not name it Beagle. It's not going to go where you want.
Never.
So you said you get about 300 submissions a year, and then those get whittled down to around a dozen?
Yes, that's right.
How many have gone through to, okay, this is all the way through the NIAC process, and now it's available to the rest of NASA to use or not use? How many have ended up in that, and how many have ended up on flights?
So we have had about 200 studies that have gone through and won. Of those, about 28 are currently going on. And so we have about 170, 160 that have finished and given us reports. It takes time for those reports to get checked for the website compliance that I mentioned earlier. So we probably have 140 to 150 final reports up online. And of those, we have had, I think, 4 space flights, 2 of which are planned. There was an ISS mission called SPIRES, where there were these little spherical robots that, if you're a Star Wars fan, I've mentioned Star Wars twice and Star Trek none. That's bad because I'm more of a Trekkie than a Star Wars fan. But if you remember in A New Hope, the episode 4, the first movie, Luke Skywalker is training with a lightsaber on the Millennium Falcon, and there's this little round robot that jumps around and throws bolts at him, right? Mm-hmm. Spheres is something like that without the energy bolts. The idea was that these free flyers in station could use cold gas, compressed cold gas, to jet around on the space station, and it got to fly. And that was Dr. David Miller out of MIT was the PI. And he used technologies that he developed in his NIAC study back in 1998 or 1999. Those technologies morphed and changed and were incorporated on those spheres. And so that was the first one. We had some small chipsets were just tested by Professor Mason Peck from Cornell. He was a NIAC fellow, and both of those gentlemen, NIAC fellows, were both chief technologists of NASA. So they went on to do great things, like many NIAC fellows did, and have done, and will hopefully continue to do. So those chipsats came out of Mason Peck's study back in the first program. Both of those are first program. So the NASA Institute for Advanced Concepts. And we have two that are getting ready. The one that I mentioned earlier, Chris Walker with the balloon mirror, and Dr. Lynn Rothschild has just been awarded a materials science study where she will take her myco-architecture up into space station to test the material properties of mycelium fungus. So this mycelium she's growing, she's a nanobiologist, and she's growing these mycelium fungus that are, imagine holding a piece of balsa wood that was fairly large, like a 2x4. But it's balsa wood, so it weighs almost nothing. And yet it's as strong as steel. And that is what she is doing with these mycelium fungi and growing them. So it's conceivable she would be able to fly essentially seeds and water.
Spores.
Spores.
Sorry.
That's right. It's exactly right.
I can't help myself.
No. But that's exactly right. To send it to Mars, right? And then harvest water from the atmosphere, potentially, right? Or bring it with you if you have to. And then take CO2 from the atmosphere and give it to these fungi. And they'll take the carbon and they'll use the oxygen, but the carbon grows their sort of body, and a form of in-situ resource utilization. You are building a solid beam out of the air on Mars. It's just super cool. So.
And these are all online. I mean, looking at the NIAC website, you get to see the awards, you get to see the paper, you get to read the 45-page paper about swarm flyby gravimetry. If you need an idea for a science fiction book, this might be a good place.
Actually, it's a fantastic place. It's a really, really neat place to go. And another neat place to go is every year we, as a sort of management of these grants, we ask them to give us a report out. It's required by our rules. But, I'm not a big rules person, but I follow all the rules because I like my job. It's good. And we ask all of the fellows to come together in a conference-like organization or setting, and they brief the program office on their progress publicly. And we put it up online on live stream, live on the internet. So these folks will come up and give a 10 or 12-minute presentation about what they've done so far, and then people will ask them questions for 5 or 10 minutes, and they answer those questions. And we have speakers come to inspire everybody and to go above and beyond for our little program. And it's a really neat thing, and we open it to the public. The one coming up, we don't have the registration website up yet, but it'll be in Tucson, Arizona. I think it's the last week of September. It might be the week to the last week of September. But so we're working with the university there to make it a really fun event, I hope, for everybody involved. But we actually have an external counsel that helps advise us. You're too close to science fiction here, or this is really boring, go do more exciting stuff, or you don't have a whole lot of dark matter astrophysics. Can you tell people in the community that you want more dark matter astrophysics stuff? And they help us do a good job for the American taxpayer. And on the board is one Dr. David Brin, who is in fact a science fiction author. Yeah. And so he comes and he's probably the one that asks the most questions of anyone, and I'm not sure why, except that maybe he's trying to get ideas for his next book. I have no idea. Very complimentary, if so.
I will not be proposing the Curved-Crease origami for various reasons, largely because it's a mechanical problem and I'm a software engineer. But I have other ideas, so I think you will be hearing back from me.
Now, Yeah, software engineering is a tricky one to propose to NIAC. We are specifically not supposed to do tools, engineering tools. Like we are, even if it's the most amazing new form of CAD that could ever be, that's not what we do. So you have to be careful about that. What I would suggest for you is to drop me an email and we can talk about it, of course.
I probably will. Yes. I need to flesh out what I have a little bit further, but we'll see.
That goes for all of your listeners too. So, and if you're interested, if anyone is interested, our website can be found at the shortcut www.nasa.gov/NIAC.
And there will be a link in the show notes.
Excellent.
Jason, do you have any thoughts you'd like to leave us with?
I get to do some really fun stuff, but like every human, some days are more challenging than others. And so I think it's really important everybody remember, engage your curiosity. We live in an amazing time where literally all human knowledge is in your pocket. It's absolutely incredible. And with some of the new form of classrooms that have sprouted up and everything, you can literally learn anything that you want. And if you go out, if you're having a bad day, go out and learn something. It'll cheer you up.
Oh, that's a good idea. Our guest has been Jason Derleth, Program Executive for the NASA Innovative Advanced Concepts Program.
Thanks for joining us again, Jason.
Thank you for having me. It was a great pleasure.
Thank you to Christopher for producing and co-hosting. Thank you to our patrons for Jason's mic. And thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now a quote to leave you with. Let's just go with Andy Weir in The Martian as the poor guy is trying to figure out what he has. Also, I have duct tape. Ordinary duct tape, like you buy at a hardware store. Turns out even NASA can't improve on duct tape. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.